Hello, everybody. Welcome to Coach Jay's study session. This is Algebra 3, 4.5 to 4.8. Hope you're having a great night tonight. I know that many of you are at home studying for some anatomy, studying for some Algebra 3. Good news is that by the end of tomorrow, you'll have some relief. We'll have some Friday football. Friday Night Lights a little bit, band, and obviously cheerleaders with that. So really excited about tomorrow, ready to get after it with you. Now, with that being said, an important note, if we end up having 10-minute classes or 10-minute breaks between classes, make sure that you come as soon as possible so that we can start right when the bell rings so I can give you enough time to be able to finish that test. All right? Hey, right before we do, I've got a little bit for you, if you don't mind. All right, you good with that? All right. So real quick, I'm sorry. This is really embarrassing, but turn up. Here we go. Okay.
You already know what it is. Solid talk, solid talk, solid talk. Don't it do it for me? Now watch me whip. Now watch me, nay, nay.
I had to do it. Even on a study session today. I told you I'd give you something crazy. We're going to have some fun tonight. Again, I know we're studying. I know we're doing crazy stuff. We're going to have some fun tonight. All right. Hey, if you have a question, this is how it works. If you've never been on a study session with me, the number you call is 770-757-2240. I said call. Please don't call. Please text me. That'd probably be better because I'm on a podcast, obviously. So if you could please give me a text there, that would be great. Please give me the number that you're confused on, or if there's a problem that I'm currently confused, that you're confused on, you could text me that at any time, and I'll try to go in the queue by the order that it arrives with me. All right. Remember that tomorrow is a non-calculator section. It is over the graphing and the inverses. So we're going to spend a lot of this podcast kind of focusing on those things. If you're looking for help on the other section, you can go back to the previous podcast, which is below this one within the Chapter 4 section of the Chapter 4 of Haiku. So we'll go straight below that, have some fun there, and then we'll rock and roll. Also, if you could put your name with that text message, that will help me to be able to identify who is who, and then also be able to answer those questions as soon as possible. My phone's already ringing off the hook. Hey, what can you say? I'm popular. Hey, a little shout out real quick. Shout out to Travis, Dirty Rhombus. I just know you're listening. I don't just know it is. And a little shout out to my friends in Sweden and India. I think there's a couple people listening from Canada. You know, I'm just popular, just a popular person. People watch me for my dance moves. People watch me for the math skills there. It doesn't matter what it is. If we were to watch podcasts with Coach Jay tonight, if you're here, pumped you're here. Thank you so much for taking time out of your night. That shows that you care, and I truly appreciate it. Before we go any further, one piece of information I'm going to give before I get to all these text messages that are blowing up on my phone. I want to first start off by saying that if you end up bring tomorrow that extra graphing section, you will get bonus. The second bonus that I'm going to offer you is actually not on the test like last time. It's actually if you watch this podcast. Here's the deal. If I feel like it has been shared with more, like right now, I have 8 viewers on this. If I feel like it is more than 8 viewers and it starts passing along, then I won't allow that to happen again, or I won't take that bonus when I go forward. So here's one thing that of note: if you end up putting Michigan on the top of your paper next to your name, if you forget, I'm sorry, just how it goes. If you end up putting Michigan next to your name at the top of your paper, and next to Michigan, put Michigan number 1. Michigan number 1. We'll change it up a little bit. That just will let me know you watched this podcast, and I can give you some bonus points on that. I don't know how many, but something's better than nothing. Again, please be sure you do that. If you forget, I'm sorry. It's just how it goes. You're just going to have to remember. Please don't tell anybody that did not watch the podcast, and we should be good. All right? Hey, let's get to some questions here. And once I get to the questions, I'm going to go all the way up through 8:15. I'll do as many questions as possible. You can call me Dora the Explorer. You can call me whatever you want, as long as it's good, as long as it's a good name. But we're going to have some fun doing some math problems here tonight. All right. All right. We're going to go right straight to our active inspire here. There we go. Very nice. And I'm going to go straight down below. Man, we got a lot of people here today. I love it. It shows me that y'all care. We're going to go to our first one. It says, oh, I'm sorry. There's a question. Is the review due on Monday? Actually, it is. It's due on Monday. However, I would definitely focus in on some of those questions related to the inverses and the graphing. All right. All right, Justin. Justin asked the question number 6. I hear Justin's a decent FIFA player. I don't know if that's true or not, but we're going to go to number 6. Hey, make sure you tell me whether it's number 6 of the inverses or the graphing. I'm going to guess it's with the inverses because that is a difficult one. But just make sure you let me know so I can take it and go from there. All right. So again, if you have another question, get in on the queue so you have time, and we'll go from there. All right. Hey, first thing is this. One thing I'm going to give to you is that with the inverse of sine, cosine, I'm just using shorthand right now. Sine, cosine, and tangent, we have the inverses within the first quadrant. Nothing can be within the third. I also know that with the cosine inverse can also be in the second. And sine inverse and tangent inverse can be in the fourth, all right? That's important. Now, if I ended up doing one like this, that's tan inverse of square root of 3 over 3, and I think it might even be negative. I think it's negative. Yeah, let me make sure. Yep, it is negative. It is negative. What we're going to do is we're going to try to solve for tangent inverse of negative square root of 3 over 3. Now, one thing I do is I always put what quadrants can tan inverse be in. Well, first of all, I know it can be in quadrants 1 and 4. And I know that in quadrant 1, it'd be positive, where quadrant 4 would be negative. Now, when you end up going to those negative values, or those values there, we notice that the inverse has a negative square root of 3 over 3. So in knowing that, I know that I'm going to be in quadrant 4. Okay, so that's my focus area. Now, not only am I in quadrant 4, but I also then see that since it's tangent, I'm going to look to see what has the value of negative square root of 3 over 3 by doing y over x. Now, I don't have a unit circle here. I probably should have put one up here. But when I look at this quadrant 4, notice that in y over x, I'm looking, because of that inverse, I'm looking for the angle. It's important. Anytime I have an inverse of something, I'm looking for the angle where the value of tangent is negative square root of 3 over 3. So I have 3 different places. I'm going to check all 3. However, I could start from the top. I mean, you could start from the bottom now we're here. You could do that, but for me, I like to go straight to the first one. All right, we'll go to square root of 3 over 2, comma, negative 1/2 at the value of 330, or as I like to say, it will be 11 pi over 6. So we're trying that first. And in trying to check it, we do y over x, knowing that y over x relates with tangent. So I'm going to do the y, which is negative 1/2, over the x, which is square root of 3 over 2. So what I'm going to do is do the flippy thing, multiply by the reciprocal of 2 square root of 3. Little cancel party, never hurt anybody. And when I cancel, I'll end up getting negative 1 over square root of 3. Now, I like to multiply now by the top and bottom of square root of 3. To where when I get the answer, I get square root of 3 over 3 with a negative sign attached to it. So guess what? Look at that right there. I've got my tangent inverse, negative square root of 3 over 3. Because of that now, I have 11 pi over 6 as my answer. Now be careful. 11 pi over 6, when I find that, you got to be really, really careful on that, because 11 pi over 6 goes outside of my range to get inside. So anytime it's in the fourth, only when it's in the fourth, you're going to go, instead of 11 pi over 6, you're going to say negative pi over 6. It's coterminal to 11 pi over 6, but now we stay in the range and we go downward. That is anytime I'm in the fourth quadrant. So you can write that down. If you want to get a tattoo of that, that's fine. You have my permission to do that. But no, I'm just joking. Don't do that, please. But no, negative pi over 6 would be my answer to that value. That's the angle where tangent inverse is negative square root of 3 over 3. All right, Justin, hope that was helpful to you. Again, I've got my phone going off the hook right now. Got people all over Sweden and India just going bonkers, just crazy. They're crazy for Coach J Math. It's just how it is. All right, number 10. we're going to do number 10 here. Number 10, we got JP here that's behind the plate. JP behind the plate, number 10. They call him the Mike Piazza. Mike Piazza is what I hear. I don't know if that's true or not, but if not, I apologize, JP. -3 cosine of 2 pi x, all right? -3, y equals -3 cosine of 2 pi x. Now, there are 3 things that I find within any cosine, sine, secant, or cosecant graph. Remember, with tangent and cotangent, we only have asymptotes and amplitudes, so that it's a little bit different. But with cosine, sine, cosecant, and secant, we have 3 things. We have amplitude, period, and phase shift. Now, amplitude is always the value that's in front. So in this case, it's 3 reflected, right, because the negative value. So it's 3 reflected. So we know that it will end up going up 3 and down 3. Now, remember, you can make this whatever you want, but you have the idea, just use that since we have it there. Now, period, we always have 2 pi over b, 2 pi over b. So in simplifying, b would be 2 pi in this case. So 2 pi over 2 pi cancels. What I do get is a value of 1. So my period, my length that I travel, remember, the length I travel is a distance of 1. Remember, 2 pi over b, I will give you on the test. You'll have that. Remember, b goes with the x value, so that b goes with the x value. Keep it as that. Now, phase shift is c over b. Notice there's no c on this side. So the 2 pi x is all by myself. Know what to be all by myself. Sorry. That was for you, Riley. So 0 would be the c. B would be the 2 pi. So 0 over 2 pi is 0. That means the phase shift is 0. And remember, the phase shift is always my starting point. So remember, there's 5 different values that we put on here. We have our starting, which we'll put at 0. We have our ending. Now, since the end value is 1, it's going to be a little bit different. I'm going to space this out. I'm going to say that this is going to be 1/2. This is 1. I'm sorry, it's positive 1/2. My fault. A positive 1, positive 3/2, positive 2, right? I'll put a -1 out here just in case. So what I have now is I've got 1 starting at 0, and then my distance that I traveled goes all the way to 1. So I have my beginning, middle, and end. All right, got my quarters there. We got our quarters. So all I have is I've got a graph that's got to go and repeat itself from 0 to 1. Now remember, when we have a negative or reflected amplitude, what we have now is we start from the bottom. Now we're here. All right, we'll start from the bottom. The whole team will be here. Okay, the whole team will end up being here for this one. All right, so we start from the bottom. We go straight through the x. Okay, remember, this is with cosine. If it was sine, it would go straight through or straight down. But we go straight through the x and hit the top there. Okay, hit the top. All right, the next one comes through this next x, right? And then it's going to hit the bottom of the value of 1. So it should look something like this. Now, that's 1 period. If I asked you to graph 2 periods, literally all I'm looking for is just kind of do the same thing. So I know it's 1 value away. It's going to go through. The next one's going to go up. Now next value is going to go through, right? I'm just spacing it out, a little bit. So now I've got 2 periods, but the main period that I'm looking for is the one between 0 and 1. Okay, that's the one that's significant to me. All right. All right, JP, hopefully that was helpful. I'm going to erase this. If you need this, you can actually go back on it on the YouTube link and rewatch it. But that's how you would do the this one here. Okay. All right. Colin Poole. All right. Let's see here. Colin Poole. They call him CP3. CP3 all the way. Do you know Colin's from Montana? I never knew that. Never knew Colin was from Montana. He actually told me the other day. He told me the other day he's from Montana. All right, so number 3. And now if you're really from Montana, Colin, that's going to be kind of creepy. All right, y equals 3 cosine of 2x minus pi. Y equals 3 cosine of 2x minus pi. Just like before, this is number 3, by the way, on the graphing section. Remember, or I'm sorry, I've got to do number 2. Ooh, man, that's not good. -3 sine. -3 sine of 2x. My fault. My bad. All right. negative 3 sine of, forgot what it is, 2x plus pi over 2, I think. Okay. All right. Thank you, Colin, for all of those texts there. Appreciate it. I'm getting all those. I got you. It's 2. I messed up. I apologize. Negative 3 sine of 2x plus pi over 2. Negative 3 sine of 2x plus pi over 2. I want to make sure that's right. I keep messing up that one. There we go. 2x plus pi over 2. There we go. So we have 3 things that we have here. We have our amplitude, we have our period, and we have our phase shift. Just like before, we're going to do the same exact thing. Remember, with this value, since it's negative, we know our amplitude would be 3, and we know that it would be reflected because of that negative value. Now, the next thing with the period is we're going to do 2 pi over b. If you need to, label it A, B, C. All right? Now, the next one we're going to do is 2 pi over b. So we're going to have 2 pi, and it's going to be over the b, which is a value of 2. Now, when I simplify this, I divide the 2's out to get a period of pi. Remember, period is distance traveled. It's the distance I travel within that period length. All right, so pi would be that distance. Next, the phase shift would be C over B, and literally this is what I want you to do with the phase shift, just to make sure we're right. For the C, put pi over 2, and for the B, since it's only a value of 2, put it as 2 over 1, so you don't get confused, so that when you end up doing the flipty, you end up multiplying it by 1/2. So pi over 2 multiplied by 1/2 gets me pi over 4. Now, is it positive or negative? Well, because that plus is in the middle, we're going to make it a value that is negative, meaning it will go to the left-hand side. Remember to always look on the inside for that to determine where it will travel. So that negative pi over 4, we're just going to make we're going to do this. Okay, negative pi over 4 was going to be here, 0. Again, yours could be different, and that's okay. You don't have to have the same as mine. If you don't have the same as mine, absolutely okay with that. All right, I'm absolutely okay with that. So now I've got negative pi over 4. Okay, got my negative pi over 4. That is my starting point. That's my phase shift. I know that if that's my starting point, my period length would be pi. So at negative pi over 4, if I travel the distance of pi, my end result would be at 3 pi over 4. Okay, so again, from negative pi over 4, I'm traveling a distance of pi, and I'll end up at 3 pi over 4. All right, so again, think about this. If you forget that, take negative pi over 4, add the distance, which is pi, get a common denominator of 4, but put on top and bottom. When I subtract or add it together, I'll get 3 pi over 4. If that's a struggle, hopefully that allows you to find what that ending spot is. Now the middle will then be at pi over 4 with my quarters at 0 and pi over 2. Now notice, since this is a sine, we know that we're going to go straight through the first one rather than start at the top. So again, we could start at 3 and negative 3 just like we did last time. But this time, since we know it's sine and it's reflected, we're going to go straight through. So it's going to go down, hit the bottom. Again, it's going to go through the next one, right? So if at the quarters you need to just put a dot there, then that's fine, okay? All right, that's fine. And once I do that, then I'm going to hit the top here, hit the top on this one, kind of come down a little bit. Once I come down, I'm good to go. I've got one graph, and I can just repeat this process for as far as I can go. So I just kind of do this for as long as possible. And I know it might go off my graph. I might not get 2 periods in, but I know I started here at negative pi over 4 and ended at 3 pi over 4. All right? All right. It's a great question. Colin, nicely done. Colin from Montana, nicely done there. All right. We are good there. Dynasty. All right, Dynasty, how are we doing today? Hopefully, Dynasty, doing well there. I'm reading your question. That's why I was awkwardly pausing there. This is kind of awkward. Sorry, completely sorry. Numeral 16. Numeral 16. 16 is a tough one, isn't it? Yep, it is a tough one a little bit. Yeah, it is. All right, so negative 2 cosecant of pi x. A little difficult, but y equals negative cosecant of pi x. Here's a hint for tomorrow. the best thing you can do to get the best grade possible, put as much work down as possible on this test. There's a lot of points to be had on this first part, and it's important that you understand that we've got to show work. Without showing work, it's going to be difficult to get the points that we need there, all right? Now, Dynasty, remember that with cosecant, anytime we have cosecant, we first have to graph the sign first, right? So y equals negative sine of pi x is what I graph, and once I do that, then I'm able to graph what the cosecant is. A lot of people struggle and think that with cotangent and tangent that you would do the same thing as cosecant, but these are actually two totally different things. So just remember that. Cosecant, we first graph the sine, and oh, by the way, if it was secant, we'd graph cosine prior to then graphing the secant there. But since it's cosecant, we're going to do the same thing. We have amplitude, period, and phase shift. Knowing that amplitude is negative or is 1, it's positive 1, but it's reflected, we put that down there because of that negative value. Next, the period is 2 pi over b. Remember, the a is the front value, the b is the value connected to x, and c it's just nothing. It's imaginary, okay? All right, just imaginary there. People are saying that I'm awkward. I'm not awkward, y'all. I might be Dora the Explorer. By the way, it's weird when I ask questions on here, like, hey, what would be the b for this cosecant? And then I awkwardly it's like Dora the Explorer, like I'm trying to get you to yell at your screen. So what I want you to do right now, even in this moment, I want you to yell at your screen. Ready? Yell at your screen. Ready? Talk to me. Ready? Say hi to me. Say, hey, hi, Coach Johnson. 1, 2, 3. All right. Colin, I didn't hear you. You need to start yelling, man. I was a little disappointed on that. All right. So coming back to it, we know the pi would then end up being, I forgot the 2. Did I forget the 2? What did I forget there? Forgot the 2. What did I forget on that? Is it 2 pi x? Oh, negative 2. Oh, yeah, that's great. All right, so that should be 2. This should be actually a positive 2 there. My bad. And everyone's telling me I forgot the 2. Thank you. I'm not Alvin the Chipmunk, all right? Man, I need to stop looking at my phone. All right, so as I look at 2 pi over b, b is pi, right? It's whatever's connected to x. Because it's not an actual number, that throws a lot of people off, but remember, anything connected to x is my b value. So now 2 pi over pi ends up canceling the pi's out, getting me a total value of 2. So my period, the distance I travel, would be a distance of 2. Now I look at my c over b, noting that there is no c, b is pi, 0 over anything would be 0. So my phase shift would be my starting point of where I'm beginning, okay? All right? Now, I hear my phone going off. Hopefully, if you can hear my phone, I might already throw it out the window. All right, so we know we rise to and fall to, right? That's my amplitude. All right, I'm about to throw my phone out the window. All right, need to throw that out the window. All right, so my phase shift, is my starting point, which is at 0, right? So I'm going to start by putting a value of 0 right there. So that's where I'm going to start. Remember, my phase shift is where I start. Now, the period's where I travel. Now, since I have a value of 2, it's going to be different on the x-axis. What I'll do is every 2 spots, I'll put a value of 1. So I have 1, 2, 3, 4. And so if I travel 2 and I start at 0, the distance I traveled would get me to an endpoint of 2. So I have my beginning and end with my middle, and I have my quarter spots there, okay? So now, since I've got everything that I need with my graph, now I just have to go to negative sign. Remember, positive sign would go straight through this way, right? Straight through this way. Positive cosine would start up here. Negative cosine would start down here. So negative sign, instead of going up through this first point, would actually go down through that first point. And remember, at the x's for sine, it'll hit the bottom. So or the first one, if it was negative, it'll hit the bottom for this one. So bottom, it's going to go through. What is down now must come up. On the second one, you could put a little dot there just to remind yourself. Now I've got to go through this one. So I'll make a little curve there. And then what I could do is just kind of mimic that. So I know that it's going to come here, here is the next one. Just kind of do it over again. And I'm going to hit here. All right, good. And I'm going to hit here. And then we're done. We've got our negative sign graph. But cosecant is another story. Remember, wherever I hit my x-axis, the only difference between cosecant and sine is that at cosecant, we have asymptotes that go up and down vertically, okay? Up and down. that now when I end up graphing this, I'll have parabolas that fit inside those asymptotes, okay? It's a great word, asymptotes, that's good. Fit inside those asymptotes there, and we have our cosecant graph. Really, the cosecant graph is what is in red, all right? But we'll keep both parts just so that I can check it, and in case you have many mess ups, I could give you back credit on that one, all right? All right. All right. All right, someone said go blue. You're exactly right. 14 or 16 on the first page, inverses. Let's do this. Let's go backwards. We're going to change it up a little bit. We're going to go to 14 and 16. That's Brad. I love the fact that Brad says go blue. He's a Michigan fan. You know, I'm glad someone gets me in this class. I'm glad someone actually doesn't make fun of me. You know, it's, man, gotta love it. All right, so let's look at number 16. 16 says sine inverse of sine pi. Okay, so the first thing you're going to do is this. What we're going to do is we're going to start on the inside, all right? Start on the inside. And once I start on the inside, then I can go out. So my first thing, I'm just going to find the sine of pi. Now, that's pretty easy. We should be able to just find that. We know that since it's regular sine, we're trying to get out a value. So at pi, my point on pi in my unit circle is -1, 0. So my question is what is the y at pi? Well, the y is associated with that 0. So 0 would be sine of pi, right? So that value, that 0, is the y value. So now I'm going to find what the sine inverse of 0 would be. Well, I know that within my range, it can be either 1 or 4, with the positive value being at the first and the negative value being at the second. But the problem is 0 is neither positive or negative. So I will check at 3 spots. I'm going to check at pi over 2, negative pi over 2, and 0. And as I check at 0, I notice that at 0, the point is 1, 0, right? That's that point. So this is where it becomes a little confusing. The question is at what angle or at what radians, right, the radian angle, is the y going to be 0? Well, I go and check and I see that at 0 radians, that's what I'm looking for, not the value of 0, but the radians of 0. The radians of, or the value is 0 at the angle of 0 radians. So my answer would actually be at 0. That would be what I would have there, all right? All righty. Dora, where is your map? Oh, my goodness. Dirty Rhombus says, could you do number 8? I think I already did number 8. Let me check that. Dirty Rhombus, man, I just don't. Man, this is different there. Hey, Travis, question. I think I did one very similar to that. Yeah, in fact, look at number 2. Number 2 is the exact same, okay? Number 2 is the exact same. I don't think I still have it. In fact, I know I don't. Number 2 is the exact same in the podcast. The only difference is the amplitude would then be 5/2 up and -5/2 down. But if you look at, here, I'll even show you. I'll show you on this here. Hey, what's up? Good to see y'all. All right. I'm not a chipmunk, just so you know. I'm not a chipmunk. I don't sound like a chipmunk either. Y'all are going to make me self-conscious about myself. All right. Look at number 2 here and number 8 here. Notice the only difference is 5/2 and -3. And so, oh yeah, and also the negative. So instead of having a negative sign where you go down first through the first point, the only difference is you go up through the first point with 5/2, right? Because it's positive. So the amplitude would only be 5/2 and -5/2. So I think that's pretty similar. So I'm going to hold off. If you really need it tomorrow morning, we can do that tomorrow as well. Okay? All right. Dynasty, thank you for telling me that I missed 2. I have like 10 text messages from you. So I love it. Someone just posted, my parents are going to think I'm possessed if I yell at my computer. Well, I'm sorry. Yell at your computer. You know, sometimes we have to just do things that we don't like to do. All right. There's nothing wrong with me. People are thinking that there's something wrong with me. Jasani, dude, I'm cracking up right now. I'm not even going to say what you put up there. I'm just cracking up. All right. -14 on the graph. Let's take a look at that one. I know right now I've got I could give you probably about 15, 20 minutes left. But let's look at this one. Let's go look at 14. I just got another one for 14. That means we probably should do 14. Oh no, that was Brad saying the 14 on the other one. Hey Brad, on number 14, and we're talking inverses here. Make sure you do the sine of 2 pi over 3. When you got sine of 2 pi over 3, you should have gotten the value, which was, I'm trying to do it in my head here. You should have gotten negative square root of 3 over 2, I believe. Or no, positive square root of 3 over 2 at 2 pi over 3. Once you do the sine inverse of square root of 3 over 2, you'll end up getting into the first quadrant, which would end up being the angle at the first quadrant should be pi over 3. So your total answer should be pi over 3. That may make no sense to you. If not, we can maybe do that tomorrow morning if you wanted to come by early. We could take a look at that one. But remember, sine of 2 pi over 3, it should be square root of 3 over 2. Sine inverse of square root of 3 over 2 would be in the first quadrant. That means that it would end up being pi over 3. Okay? Again, if you're confused, we can look at that a little bit later. All right, the next one we're going to look at is number 14 on the graphing portion. And did I just exit out of that? Really? Coach, come on. Man, all right, let me do this. Let me pull this up here. This podcast sponsored by Tostitos chips. When you're hungry, don't be hungry. Grab some Tostitos chips. Also sponsored, I'm pulling up this up here, I'm sorry. Also sponsored by odor eaters. When your shoes stink, make sure you put some odor eaters in your shoes. All right, number 14 on, oh, that's a good one. Giussani, that's a good one. 3 cotangent of x plus pi over 2. This one's a little bit different, and that's why we are going to do it. All right? Do it. All right. If you're weird, if you think I'm weird, just go with it, all right? 3 cotangent of x plus pi over 2. That could be off a little bit. Let me check. Yeah, no, we're good. Word in this hizzy. All right, so y equals 3 cotangent of x plus pi over 2. There are 2 things we need to find. Amplitude and, I almost said period. I didn't mean that. Asymptotes, okay? Asymptotes. All right? So when we end up finding what the asymptote is, when we find what the asymptote is, we end up solving that by knowing what we set cotangent equal to. We have to set it equal to first 0, then 2 pi. Okay, 0 and pi. So when we set it equal to 0, we set x plus pi over 2 equal to 0, and x plus pi over 2 equal to pi. Okay, I'm then going to subtract pi over 2 on both sides. Subtract pi over 2 on both sides. Okay, do it. There we go. When I do that, and again, these are 2 different equations, I cancel, little cancel party. I get x isolated. And now x equals negative pi over 2. Okay, so my first asymptote is negative pi over 2. And my second one, pi minus pi over 2, if you're confused on that, what we can do is this, get a common denominator of 2 on the bottom. We'll do 2 on the top. What I do to the bottom, I also do to the top. So now 2 pi over 2 minus pi over 2 equals pi over 2. So I have pi over 2 and negative pi over 2. Now, your values could be different. I'm just going to say every second one is going to be pi over 2. So we'll do that. We'll do that one. This will be pi. This will be 3 pi over 2. All right, we're good to go there. The next thing we're going to have is at negative pi over 2. We're going to graph that asymptote. We're going to graph the next one. And we know that the middle would end up being 0, right? So we have our first one and second one. Notice that I do not have to do period, and I do not have to do phase shift because it's built in when I find what my asymptotes are. So now I've got my beginning and my end, my 2 asymptotes, my middle, and then I've got my 2 quarters. Now note for cotangent, anytime I have cotangent rises to the left, falls to the right, where tangent is opposite. And remember, if this was negative, it would just be flip-flopped. So when I rise to the left at this quarter point, make sure I rise to what my amplitude is. So I'm going to rise up 3, and to the right, I'm going to fall down to the right 3. So I'm going to go there. Oh, I'm sorry. Little bad of graph there and there. Okay, so that would be what my first graph is. Now, since I have this, if I were to graph 2 periods, which shouldn't be a big deal, I have 1, 2, 3, 4. So we'll just do the same tick marks. 1, 2, 3, 4. Put a little dotted line there, little dotted line action, and just repeat it. Just repeat it again. Come down 3, We just do the same thing we did on the other one to find that second period, okay? All right. I don't think that their 2 periods will end up being bonus on the test. That's just my guess, Justin. I'm probably not going to do that there. Yeah, I wouldn't do that there. Hey, Colin, coming back to it, Colin asked the question, why would number 2 why wouldn't the B be 1? Remember that with number 2 on that graphing section, the B was 2x plus pi over 2, right? So when I do 2 pi over 2, the 2's will cancel out, leaving me with just pi. All right, hopefully that will be good there. All right. Yeah, I will give you 0 and pi for the test. So yes, you can do that for sure. All right, you can definitely do that for sure. I'll give you the 0 and pi there, Justin. You can be good to go there. All right. All right. Let's see, graphing number 10. I hear number 10. I think I did one very similar to number 10, if not number 10. If I still didn't get yours, you might want to come in tomorrow morning, but I think I hit 10 on that one. 12 on the graphing. 12 is one where we set x plus pi over 2. We do the same thing we just did, except now what we do is we'd set x plus pi over 2. So this is what the graph is, right? Tangent of x plus pi over 2. Oh my goodness, I ran out of ink. Oh, there we go. Yes, that's why you always have to have extra ink left over so you don't run out of ink, especially when you're on your Mac here. All right. X plus pi over 2, we're going to set equal to 2 things. Remember in tangent, we set it equal to pi over 2 and negative pi over 2. So I'm going to subtract pi over 2 on both sides. Now notice I'm going a little bit quicker than I did at the beginning. All right. And I'm not asking as many questions. So like, because Swiper right now, Swiper says no swiping. So we're going to just keep it as is. All right. Sorry about that. So right now I've got 2 things. I've got x is equal to negative pi over 2 minus pi over 2 is negative 2 pi over 2 or negative pi. X equals negative pi. And then pi over 2 minus pi over 2 would be x equals 0, right? X equals 0. So I have 2 values. One is going to be at 0. Okay, so we're going to have an asymptote at 0. And I'm going to have another one at negative pi. I'm going to make this over here negative pi. You know what sounds good? Some strawberry pie right now. Or apple pie. Apple crumble pie. Apple streusel crumble pie. That does sound good. So I've got my first one and my second one. What would I do next? Please talk to your screen. Yes, you. Talk to your screen, dirty rhombus. All right, you're very right. Nicely done, Colin. The middle would end up being at negative pi over 2 because that's the halfway point. Remember the quarters I don't really care about finding, just the beginning, 0, middle, negative pi over 2, and end, negative pi. So now, as I look at tangent will rise to the right and fall to the left when it's positive and do the opposite when it's negative. So when I rise to the right, Falcons rise up. We're going to go up to the amplitude, and we're going to fall to the left on the amplitude, okay? And that's how my tangent graph should look. Again, if I were to repeat it, 1, 2, 3, 4, 1, 2, 3, 4. We're going to go here. We're going to go down, okay? Just repeat it, mirror it over again, okay? Again, the big thing with finding those 2 periods is just imitating what you already did. Blackberry pie does sound good, by the way. Sorry about that. But yeah, when you imitate it, just basically go over. If you don't have the values of that, not really worried about it. Just imitate it, go over, and just repeat that same process again, okay? All right. Oh my goodness. I've got jokes coming galore right now. I don't know. What did I do to y'all? I didn't even do anything to y'all. Goodness. Man. All right, number 12 I just did. Number 4, Ariel, tomorrow on number 4, could we do number 4 tomorrow morning? Come in tomorrow morning, we'll look at that one together. I just want to make sure we do a variety of them, and I know we've done a cosine one, unless we have another one we have to do here. Also, Dirty Rhombus needs a homecoming date out there. If anybody needs a homecoming date, please make sure you contact Travis. His number is 678-810-677. So please call him, and we will contact him for sure. Hey, Dirty Rhombus, I already went through tan inverse of stuff. If you still need one, let me know, okay? All right. The tangent graph on the test, I think that's something we need to memorize. For the quiz, I could have given it to you, but just remember that on the test, I'm going to give you a lot of things: asymptotes, period, phase shift formulas. I'm going to give you formulas. That's more of like a concept thing, and even if you got that wrong, Jasani, that's not the majority of the problem. So I think I'm going to make you have to know that one. All right. Oh man, yeah. Travis is saying that he is talking to his screen right now, and his parents think he's crazy. Hey, Travis, whatever it takes, man, whatever it takes. All right. Make sure the Michigan #1 thing. Make sure you put that on the test. All right, on the test next to your. I'm distracted. Your texts are crazy, y'all. Oh, we just got someone. Someone just said, I will go with Travis to homecoming. Travis, you just got a date. Congratulations. All right, just congratulations. See me tomorrow. If you texted in for that, I don't want to embarrass you, but make sure you come and see me tomorrow morning during the study session. We'll pair you all together, okay? Yes, Michigan #1, make sure you put on the top of the test next to your name to get those bonus points that are there, okay? Yes, there will be cosecant and secant on and cotangent. All of those will be separate. So make sure you know how to do cosecant, secant, and cotangent on the test. That's a big deal, knowing how to do that. Some people are saying, thanks, Coach Jay, for the podcast. Hey, anytime, we just help and support out there. Someone said their dog is barking at the screen. Okay, someone else said, I'll go with Travis, except that'd be kind of weird. Colin, thank you. The dog is scared of me. Well, I've got tons of different messages there. Ariel, I'm going to come back to that question. Travis, if you really need some more help on those tangent ones, we can look at that tomorrow. But I'm going to finish off with our last question of the night. Congratulations, Ariel. We are going to do number 4 as our last question of the night. Okay? As the last question of the night. I'm not Alvin the Chipmunk. All right. Let's do the last one here. Okay, let me see here. Let me see how many viewers I have. I have 13 viewers right now, y'all. This is big time, I have about as many viewers as Pretty Little Liars did on their season opener. I should open up I should have an episode like Pretty Little Liars. Wouldn't that be great? It'd be great. I could do it, and I just do math problems on it. You all could watch it, and we could increase our following. It'd be great, It'd be awesome. All right, let's see. 2x plus pi, I think. There we go. All right, so we have 3 things when we come to cosine on our last problem of the night. The first thing is to find the amplitude. Second is the period. Third is the phase shift, right? So when we find each of those things, we know that A, B, C will help us in finding that direction. So I start with amplitude at 1/2. And note that when I find amplitude, I can go wherever I want on my y-axis just as long as I label it accordingly. So 1/2 and -1/2. Now with my period, I will do 2 pi over b. So when I find what b is, b would end up being 2. Okay, remember 2 right here. Okay, 2 is b. So when I cancel those 2's, my answer left over would end up being pi. Our period is pi. Now that's, remember, the distance that I travel. It's not the place I start. It's just the distance I travel, okay? All right, now this phase shift is c over b. So when I do this, I end up taking pi and putting it over 2. So it should be this. It should be pi over 2. Since there's no fractions, I don't need to worry about simplifying because it's already been given for me at pi over 2. Noting that there's a positive in the middle, I remember that I'm thinking opposite from the interior, so I'm going to push it to the left, pi over 2. So with it being left pi over 2, I'm going to kind of make this to where every 2 tick marks. That's kind of traditionally what I've done. So I'm going to put negative pi over 2 here, 0, positive pi over 2, positive pi, positive 3 pi over 2, and I could keep going and going and going, 2 pi, but you get the idea of how we would do that there. Now, at the beginning, since my phase shift is at negative pi over 2, I'm going to put a beginning point on negative pi over 2. And since I travel a distance of pi, if I start at negative pi over 2, my ending point would be at positive pi over 2. Okay, remember, negative pi over 2 plus pi over 2, plus pi, equals, well, I put a 2 on top and bottom to get a common denominator. Negative pi over 2 plus 2 pi over 2 gets me positive pi over 2. So that's how I got my ending. So now I've got my beginning, middle, and end. Okay, that's all I care about for labeling purposes. And I know that since I've got my 5 points, I don't add any more points here. A lot of people try to add points to the right and left. Graph this first prior to then going any further, because then I can just imitate what I have left over. Well, now since I've got 1/2 cosine of 2x plus pi, I know that cosine being positive, I'm going to start right at the top. Okay, start right at the top. Because it's positive, I start at the top, and because it's cosine, sine, remember, would go through this first point. So with cosine, we're going to go through the first, coming down through the x. Okay, then I'm going to hit the middle, except I'm going to hit on the low side here. Low side. All right, we hit through the x. And we're going to hit through the last point here. Okay, again, I could just imitate it, so I know I'm going to go through the next one. Okay, so go through the next one. This next one, I'm going to go low. Okay, I kind of just I could keep going and going and going. You could keep drawing sine and cosine graphs for forever. Keep going with the next one, and I could keep going and going. But the main one I focused on to help me set this up was from negative pi over 2 to then pi over 2 on that one. All right. All right. Awesome. People are saying go Knowles. Got that out there. Justin Parker got you there. I got other people out there saying thank you. Yeah, the second part of the test is word problems and problems from the previous section. Okay, so it's kind of a review. Remember, the second part, you're going to focus really heavily on the numbers 19 to 30. If you need help, I'll have a study session Monday morning if you need more help on that, all right? But again, remember, the review will be due on that Monday, all right? Oh, man, y'all are great. Oh. All right, I'm laughing. I've got too many good text messages to throw out there. Everyone dissed me about my height, my podcast. Hey, don't diss me because of my podcast. I just helped you out for 50 minutes. Hopefully, because of this, you're going to dominate that test tomorrow. Hey, if you need some more help tomorrow morning, be there, be square, starting at 7:10. Some people come a little earlier than that, 7:05. Come on, get some more help tomorrow. We'll dominate this test. We'll get it done on Friday, all right? Hey, love y'all. Appreciate y'all. Have a great, great night. Stay classy. GAC. See y'all. Bye.